Good afternoon. Okay, so let's begin today. I wanted to show you, first of all, I'm going to keep really emphasizing style in this course, and in particular commenting. And I wanted to show you right away the benefit of commenting in a certain specific style, so that later on when you have a project where you've written hundreds or thousands of lines of code, the documentation just gets generated automatically, and you don't have to do it by yourself or go back and try and figure out what these functions did that you wrote 6 months or a year ago. Okay, so let me show you. There's a program called DOxygen, and it's installed on the PicLab computers as well. And basically what you do is it allows you to take this documentation style that I introduced yesterday, where I have this @name page, @author, @date. It looks kind of like the syntax for commenting that's in your book, because it's based off the same principle. And then, for example, I took the lecture 1 code and I just put it into a function, just to kind of clean up the main. So there's nothing in main now. But then for this function, I did a very specific style of commenting, like so. And then what you'll see is that if you run this program, it'll take all of this material here, and it will, I need /n's to denote new lines, but it will put in new lines, and it will just give us a documentation automatically. So I'm going to select the appropriate location. So we're at pick 10b, fall. We'll just leave it here. And then source code directory, we'll do the same thing. Oh, have to. Okay. Users, pick my docs, fall. Okay, so this is where my code is, and I click the scan recursively. That way, if there's more folders with various files, it just goes and grabs everything. And then the directory where I want to put everything when I'm done, it's going to be the same. It's a lot of clicks. Whoever designed this interface is... OK, here we go. All right, click Next. And then all the rest of the default settings are fine. All you got to do is tell it what file your code is in and comment it right. And now you click Run DOxygen. And it takes a second. But then, OK, so it's finished running. Show HTML output. And there we go. Oh, it kind of worked. Huh. Why didn't it pick up? That's kind of weird, but it did sort of work. Sort of. Okay, so it gave us the header file lecture 1, lecture 2. It gave us the text that we wrote. So I will post updated versions of this file on CCLE as we add more content. So I'm not sure why it didn't. It picked it up in 10C, so I did it almost exactly the same. That's how it's supposed to look. Something like this. None of that text box, but that's a detail. Okay, so the idea is the following. As long as you diligently code up all of your functions in the way from the syntax from the book, this will automatically generate documentation so that when you've got hundreds or thousands of files, that it can at a bird's eye view, you can very quickly figure out what you coded up and what it does. Okay, so that was just more motivating. Here is a wish list of things to cover today. So I'm going to start with an example of a fraction class. So we're going to make a fraction, and then we're going to live the dream, right? So if we create a fraction object, we'd really like to be able to do like f plus f2, right? I mean, it's a fraction, it's a numerical object, but it only works for ints and doubles, but C++ lets us define some of these numerical operations. Okay, so that's what's really, really kind of neat about this. What we're going to be able to do is the following. Create, say, a fraction class. So what I usually do is I start a wish list of syntax I'd like to be able to do, and then I'll show you how to actually make it compile. So I create a fraction f. I might want to initialize it with, say, a numerator and denominator, say, like a 5 and a 10. Okay, maybe I create a fraction f2. Well, maybe not 5/10, maybe 5 over 11. And then f2 would be something like 2/3. Okay, and then I'd like to be able to do things like C out f plus f2. Okay. Now, that obviously doesn't compile because, well, I haven't even defined what a fraction class is. Okay? But let's define the fraction class first, and then we'll then try and figure out how to define this plus and other numerical operators afterwards. So we create a class called fraction. And now what should be the member variables? Numerator and denominator. Now what variable names does your book use? Anyone read the book, chapter 14 already? Or at least glanced at it? He uses top and bottom. I don't like that. It's numerator, denominator. Those are the technical terms. Those are the terms. They're unambiguously clear. What do you mean by top? You know, like if you have a stack of books, there's like a top there. But it has nothing to do with that. There is a numerator and a denominator. Okay? My convention is, if it's a variable that's a single word, you just make it all lowercase. Int numerator, int denominator. Okay? I need a semicolon at the end there. Okay? Now, public, I need to be able to construct a fraction object. So there is a, well, should we make a default constructor? What do you think? Yeah, what would the default constructor maybe initialize the fraction to? 0 over 1 is probably a fair initial value, right? Okay, so let's while we're making the class, let's throw in a default constructor. Well, what if we did a fraction with a single int? How might that initialize it? The value of that over 1, right? To give you an idea of, okay, well, I can, a fraction is really just a more general sort of form of an integer, right? So if I try to do a fraction and initialize it to value 5, maybe I could probably mean 5 over 1. That's reasonable. Okay? So again, you can do whatever you want, right? I mean, this is the beauty of C++. You write the function yourself, so you don't have to, by default, let the fraction be 0 over 1, or that equivalent. You could have it be 0 over 0. But you want to make a library, you want to make a class, you want to make this functionality intuitive so that somebody who doesn't really know all the details will still be able to relatively quickly get up to speed. Okay? So this would be, say, input numerator. And then we can create another one, int input numerator, int input denominator. Okay, so now we've declared them. Now let's go down below and let's define them. Okay, so this is a fraction constructor. So let's start with the default constructor. All right, what should I write? Numerator equals 0, denominator equals 1. How many people have not heard of a field initializer list? Wow, okay. That's fine. That's fine. I'm going to go over it right now. This is the first way you can construct an object with the numerical values of its variables. Okay? This is one way to do it. So here's what actually happens when you do it this way. Okay? So this is the default constructor. There's no input parameters, there's no output parameters, so there's no @param. That'll come later. But let me just outline the steps of what happens. So the first thing that happens is numerator and denominator are default initialized. So what value do they have? Well, forget about this code that I've written before. If you create a variable called like int a semicolon, yeah, so in general it's undefined behavior. Most of the time it'll give you some random number, but technically speaking, it is undefined behavior. It could crash on you, it might not compile, but most of the time it allocates some memory, Whatever zeros and ones were there before are still there. It just interprets it. But the point is that first things first, it creates space for numerator and denominator. Okay? Then it runs the code inside that. So what it does is it initializes first, and then it assigns the value. So that's 2 steps. And that's a little bit of a waste, right? Because if you do int a, semicolon, and then a equals 5, first it goes into memory, creates it, comes back, and then it goes back and assigns the value. So that's too much traversing. A lot of times what we want to do is create it and initialize it at the same time. This doesn't seem like a big deal when you're dealing with a couple of ints. But when we do polymorphism and inheritance, this is going to be actually a much more integral part of the discussion. Okay, so right now, that's what it does. It creates numerator and denominator variables, and then it goes and assigns them the value of 0 and the value of 1. Okay, so this default constructor initializes the fraction to 0 over 1. Okay. Now this initializes fraction to input numerator over 1. Okay? This has a parameter, so we do @param. We name the variable, and then we describe what it does. So this is the value of the numerator. Okay. There's no return value in a constructor. Okay? A constructor is just a set of code that runs. It's not, strictly speaking, the same thing as a function. Okay? So what am I going to do here? Well, now I'm going to do something slightly different. So let me show you how to do the field initializer list syntax. Okay? So, like I said, you create the variable, you come back. You get the value, you assign it, you come back. Let's just do it all in one fell swoop. You do it the following. You do colon space. You name the name the member variable, numerator, and then in parentheses you put in a value, like for example 4, or you can name a parameter from the input list. So input underscore numerator, and then I want to assign the denominator as well, so I do comma denominator, and I'm going to initialize that to the value 1. Now there's nothing in the middle here. Oh, OK. I forgot fraction, colon, colon. Okay. So now let me comment out this line here. That's going to not compile, this f plus f2. But now everything else we've done is going to compile, except for, of course, we're not done yet. We did the default constructor. We did the constructor with 1 parameter. And now we're going to do the constructor with 2 parameters. So again, this is a constructor of the fraction class. So initializes fraction to input numerator over input denominator. At param, input numerator is the initial numerator. Copy, copy. OK. Input denominator is the initial denominator. Yes, this commenting is so important. I'm devoting class time to just get it in your brain. If you write a function, you have to write comments. OK, so here we go. Let's do the same thing. Let's make the field initializer list that just initializes numerator to the input numerator, comma, denominator, input denominator. Okay? And now there's no code to run. Okay? It's just blank. All right? Now this should compile. Indeed it does. Okay? So I've created these 2 fractions. Now, being able to see out a fraction is, we're going to have to wait on that one a little bit. Okay? But maybe I'll make a function called f.print. Right? Let's do a function called f.print. So again, I put in my wish list first, and then I put in here print. It's a void function. What should this print function do? yeah, I should just print, you know, the cout numerator, right? And I can just write numerator because it's a member function. Then we want a let's see, which way do we want it to go? Is it that way or is it, wait, I think it's that way, right? Yeah, okay. That one, denominator. And I'm not going to put in an endl because maybe you want to print it out and then on the same line do something. Okay, so just print out numerator divided by denominator, and then, okay, you can add in an endl afterwards. This is a void function, returns no parameter. So I have to put that in here as well, void. Okay, now this code should print, so let's see, hopefully this will print out 5/11. And it does. And we get the press any key to continue right after the last one in the 11. Okay? So I can even do things like f.print, cout plus, well, just do the plus, and then do f2.print. I can do things like 5/11 plus 2/3. Okay? So this is the beginning of, all right, it's a review of, here's the constructors, you got to initialize the variables. Now we created a function called print. Let's create a function called plus equals, just like in your homework. Okay, and I'll show you why in a minute. So we're going to create a function called, we're going to return a fraction reference. I'll explain in a minute, but we'll call it plus equals. And then we're going to input a const fraction reference, let's say, right-hand side. Okay, so let's define this. And I'll explain what I mean by fraction reference in a minute, which is okay, so this is a member function called plus equals. So how is it going to be called? It's going to be called in main like the following. We're going to say something like f dot, and there it appears. See here how it appears? So I think Xcode does this as well. Just, you know, your options just kind of appear. So we do plus equals, and then we're going to input the f2, right? And what this means is, okay, we want to take the current value of f, and we want to add f2 to that value of f. Okay? And again, C++ has no idea what a fraction is. It has no idea what fraction arithmetic is. But you're going to tell it exactly what operations to perform when it calls a function like plus equals. Okay? So here, what we're trying to write is something equivalent to f plus equals f2. If these were int variables, this would make perfect sense. You would know exactly what I was talking about. What we're going to do is we're going to attempt to extend that functionality to whatever class that we've created. Okay? So fractions are a very natural class to try this out on. You're going to do it for polynomials. That's going to be a little bit more challenging because you have a vector of coefficients, but in principle, it's exactly the same. Okay, so we have our plus equals, and what do we want it to do? We want it to, well, how do you add two fractions together? So first, let me just put in the comments here. Prints out the fraction in the form n over d. Okay, this one, you know, performs f plus equals f2, where f is the object calling the function. Or really just right-hand side. F plus equals right-hand side. Okay? So at param, right-hand side is the fraction object to add to f. Now, why would I make it const fraction reference? Why is it const fraction reference? When do you make a variable const class reference? There's two reasons. What's the first one? You don't want to make a change. You don't want any change to occur to that object. And then two, why the reference? It's quicker. Do you know why? Was this ever explained? Yeah, because when you create a reference, you don't create a new object. So this is like, this is really is a non sort of mathematics thing. Okay, usually when you think of like 2 plus 5, you think of that as a 7, but you don't really think of like 2 plus equals 5, right? Because you can have a variable and you can add something to the variable, like a plus equals 7, but then there's this notion of there's a value, this abstract notion of a value, but then there's an actual object that contains that value. Okay, so when you pass in a fraction which has value 2/3, the question becomes, do you want to pass in the abstract idea of 2/3? You can't really. You have to associate that idea with an object. And so you can either let the function access the object itself, or you can make a copy of it and pass in the copy to be utilized by the function. And so that's what the reference is doing, the ampersand. It's basically saying, right, well, that value is already stored in some object. The reference means just give this function access to it. And the const means don't let it change anything. Okay? And that prevents it from making a copy. And if the fraction object took up, hundreds of megabytes of memory, we might make a very expensive copy. This allows us to just access the value without making a copy of it. So how do we add two fractions together? Okay, well, let's just do it in a over b plus c over d. All right, what is it? A times d plus b times c. Is that right? Okay, divided by b times d. Okay, so what we need to do is we need to replace f's numerator and denominator with these two values. Okay, so let me suggest the following idea. Again, you could write something like numerator times right-hand side dot numerator plus, okay, but let's just do it. Does this abstract notation make sense to everybody? Right? If you came back 6 months from now, would you be able to read that line of code? Yeah. I mean, I wrote it right in front of you right now. You all know what's going on here. So let's just do the following. Okay? Int a equals numerator, int b equals denominator, int c equals right-hand side dot numerator, int d equals right-hand side dot denominator. Okay? Now, numerator is going to equal what? Right? I'm going to replace the a with this top part. I'm going to replace the denominator with the bottom part. Okay? So now, once I understand that this function is just taking an a over b and replacing it with an a times d plus b times c divided by b times d, by just creating these 4 extra little local variables, I can write code that's a bit more readable. Okay? Trust me on this. It's worth it at this stage to write readable code. Okay? Plus, the compiler may even optimize away those 4 variables you've made. The compiler may be smart enough to say, oh, wait a minute, this function can be optimized in a way where all that goes away. And it becomes even more efficient than you could even try. Okay? So my emphasis is write code that's readable, that you could just look at again 6 months from now and be able to discern. Okay? It'll make every other aspect of programming much more enjoyable. All right? So here we've said we're doing a over b plus c over d. It equals that formula. That's elementary. And all we're doing is we're setting up the a, the b, the c, the d, and then we're saying just replace those values accordingly. Okay. Now let's do f.print, and let's see what happens. Well, let's do end else. Oh, what doesn't it like? Oh, yeah, it's got to return a value. Okay. Now, what is it going to return? It's actually going to return. How many people have no idea what I mean when I say this pointer? How many people have no idea what I'm talking about? Never heard of the this pointer? Be brave. Be brave. Come on, get them up there. Okay. So you guys all remember what pointers are, right? Okay, pointers point to some type of object. In every class, in every member function of every class, there is a keyword called this. And what is this? This is a pointer to the object that called the member function. Okay? So here, we've updated the object that called the plus equals function, and now we want to return the object itself, a reference to the actual object itself. Okay? So if we want to access the object that called the function, we need some way to do that. And the way we do that is called the this pointer. Okay, so what we're going to do is we're going to return star this. We're dereferencing the pointer. Don't worry about this so much right now. Okay? Just accept that we need to return something, a fraction reference. We need to return a fraction that already exists, and the fraction that we want to return is precisely the one that called the function in the first place. Okay? But for now, if you see fraction reference, you're just going to return star this, and just leave it at that for now. Okay? We'll do a couple more examples later on, and you'll get a better idea of why. Okay? So now that we have a return value in place, now it compiles, and here we go. 5 over 11 plus 2/3 equals 37 over 33. Seem reasonable? Yeah. I got the denominator right, definitely, by glancing. And then let's see, 15 plus 22, is that 37? Okay. So we did something right. All right, now, how many of us would love to just write f dot plus equals all day long? Or read f dot plus equals all day long? We wouldn't like that very much. Okay? What would we rather see? We'd rather see this line right above it, right? In comments, I wrote, oh, well, this is what you mean by it, right? My comment is a mathematical formula, f plus equals f2. You all know what that means, right? I don't really need to spell it out. And so what I'm saying is, all right, now here's how you can actually get that line of code to work. Okay, so it's going to be exactly the same as plus equals. Here's how you do it. You write fraction reference, and now you can write operator plus equals. Oh, look, see what happened to operator? What color did it turn? Must be deprived of oxygen. No, okay, so operator is a keyword. Operator is a keyword, which means this is not just a regular old function. There is something special about using the keyword operator, because you can't put symbols in a function name, right? You can't write a function called 5 plus 3 in words and then put like a plus symbol. It won't work. But you put in operator, turns blue, and then you put in a very specific type of symbol or collection of symbols, and now something magical happens. Okay, so let me show you what happens. So it's gonna have the exact same syntax as our plus equals function. Now I'm going to go further down. Okay, so we go here. Fraction colon colon. Now what I'm going to do is I'm going to just steal all this code. Okay? The reason is you would never copy and paste code like this, but the reason is because I'm going to get rid of this plus equals function. Okay? I'm going to get rid of it. I don't like it. I can always bring it back, but if I have the option to call a function called plus equals versus an operator that is essentially plus equals, I'd rather go with that. So let's see. Identifier. I'm missing a semicolon. It compiled. Okay, let's run it. No, looks the same. Okay, so it's that operator keyword. That operator keyword up above here, this is what basically says, all right, well, this is a function, but if you want to call this function, you don't need the keyword operator. You can just write f plus equals, and that's equivalent to f dot operator plus equals, and then in parentheses, f2. And just to show you how literally that statement is to be interpreted, I can literally call, instead of f plus equals, I can literally call f dot operator plus equals f2. It literally gets mapped to the same thing. It gets translated to the same thing. Okay? So what we've done is we've created a function called operator plus equals. It is a member function. Object f calls plus equals. And what this syntax tells you, what the operator keyword, it turns blue because what it means is there's a different way to call this function. You can call it like it's a regular old function. It's called operator plus equals. But this is the beauty of C++ is that, and other languages as well, is you don't need to include that operator keyword. You can literally write it as if these were two ints or doubles. Okay? So that's the key. Okay, that's step number one. Now the same thing will work with operator minus equals, times equals, divided by equals. Okay, it's the same thing. All right. What about operator plus? Okay, so again, we could write a function called add or addition and do f dot add of f2, but that's not what we want. That's not the code we want to write, right? What we want to do is write something like the following. We want to be able to write like fraction f3 equals f plus f2, right? Well, of course it's not going to work right now, but that's what we want. Okay? We want to be able to work with fractions as if they were ints or doubles. So how would we write this? Well, this is where there are a lot of different ways you could come up with logically to write this, and I'm going to tell you a preferred style choice. Okay? So, and I think you'll agree this is a really good idea. All right? So again, you can copy and paste the code, you can rewrite the code and redo the addition between two fraction objects, but that's bad. What I'd rather do is use code that I've already written to define this new function. So first, there should be some way, there's a, so this is a, operator plus equals is a member function. Okay? Now, operator plus is going to be a non-member. Okay? So operator plus, again, operator turns blue because we're creating a function that can be called using the word operator plus, or just by invoking plus in a certain way. Okay, that's the idea. So what are going to be the two input arguments to operator? If it's non-member, we have to input both the left-hand side of the plus and the right-hand side of the plus. Let me suggest the following way. There are many ways you could come up with to do it. Let me suggest the following method. Fraction, let's call it left-hand side. And note, it's not by accident. I'm passing that in by value. And then I'm going to pass the right-hand side in by const fraction reference. Now, what should be the return type of this function? A fraction, right? Not a fraction reference, but a completely new fraction object. If I add two ints together, int a, int b, and I do a plus b, well, a and b are going to stay the same. They're not going to change. And we're going to have to create a new variable in order to store the result of their summation. Same thing with a fraction object, but now you have a little bit more of a window into the logic behind the input-output structure. In other words, we are going to take these already existing fraction objects and we are going to create a new fraction object and return it. Okay? And return its value. So in particular, this is a non-member operator, a non-member function. Okay? So let me define it. here's how slick it is, all right? Again, you can come up with a bunch of different ways to do this, but here's what I suggest. Watch this. If I try to access the numerator and denominator of these objects, what's the compiler going to tell me? Let's do it. Let's just see what happens if I try to do, right? If I try to do left-hand side dot numerator, what do I get? Private. Okay? So I can't access numerator and denominator. It's not like a member function, right? In this plus equals, it's a member function, right? So I can access them however I want. But when you have a non-member function, by default, you can call a member function, a public member function, but you cannot access the private members in general. So check this out. So this is a style choice which I am going to impose on every single one of you. And for your homework, this will actually save you a lot of time in coding, especially for homework 3 when you make a rational class. You're not going to be writing really any more math code. It's just going to be logic. Here's what you do. You write return. And again, you can't access numerator, denominator, but what you can do is you can take this left-hand side. Can I modify that variable? Yeah, right? I pass it in by value, right? So I made a copy of whatever the values were. What if I plus equaled it with the right-hand side? Well, now think about that for a minute. First of all, operator plus equal is a public member function. So I can call plus equals wherever I want on any type of fraction objects. Second, have I modified the left-hand input argument? No, because I've made a copy of it. Okay? I was going to have to make a new fraction object anyway, so I might as well let the function parameter aspect make a copy of it and then modify that value. Okay? So I'm passing in a copy of the left-hand side's value into a new fraction object. I'm modifying that copy, and then I'm returning it. Okay? So I haven't modified the right-hand side at all. I haven't modified the original value that was input here because I've made a copy of it. And then I'm returning this new value, which should have the appropriate value. Does this kind of make sense? It will sink in eventually. Okay, the more you do this, the more it'll make sense. The reason we do it this way is because did I have to write any more math code? Did I have to think about numerators and denominators? No. I got rid of all that low-level thinking, and I've replaced it purely with logic. Not math, logic. Okay? So comments here, comments here. Again, let's just put in a reminder. I should fill in comments. Now if I go back to main and I try to do something like this, if I recompile it, no problem. Okay? Now I try to f3.print. And there we go. So what I did was, okay, so I took, f as 5 over 11, and I added f2 to it, and then I took f3 to be f plus f2 again. Okay? So I got my new fraction. Okay, so any questions so far? How would you do subtraction? Find the. Are you saying take reduce it first and then do the math, or?
Start to write the function to find the biggest common factor with the numerator and denominator.
So what you're trying to do is you're trying to simply reduce it and do the arithmetic. Yeah, let's not do that. Okay? So there's going to be a very strong desire, especially with fractions initially, to want to put them in reduced terms first. That's fine. We can make a function called reduce that simplifies it. But we want to keep that logic modularized and separate from a function that just subtracts two fractions together. Yeah. So that is the next step, though. The next natural thing you would ask is, well, okay, let's say we add these two numbers together and we end up with a value of 2 divided by 4. What should we do? And the answer is you should call a function called reduce after every arithmetic operation that essentially reduces the fraction to its lowest terms. We'll get to that next time. Okay? But for now, just think about the most... We won't do the minus equals right now. This is more of like an exercise to think on your own, and next time I'll do an example. Okay? Think about a minimalist approach. And again, it's not about efficiency. This is not about like making really fast code. This is about if something goes wrong or breaks, you only really want there to be a few locations where you're going to have to make changes. Okay? So the question is, once you've written code to add two fractions together, there's an abstract notion of how you would maybe do one thing first and then call the add function again. Okay? And then there's the next step of how would you code that up in C++. Okay? So yeah.
For that, could we do operator overloading on the negative sign, and then we could just use that to add it to, like, do a negative operation on one of the fractions and add it to the other?
Exactly. So what he's saying is, can you just negate the right-hand side first and then call the addition? Yes. Okay? That's how you should be thinking. Rather than saying, oh, well, let me just go into this code for plus equals, copy and paste, and replace the plus with a minus in the numerator. Okay? That's how you should be thinking is, okay, I should probably just create a function called minus. Let's do it. Okay? This is absolutely doable. There are a couple different ways to do it. Let's do the member version. Okay? Why? Why? So why would we call the member, why would we make a member function for operator minus? It's because we need to actually modify the private variables. Okay? So we want to take, say, 5 over 2, and we're going to replace it with what? Negative 5 over 2. Okay? Or we're going to create a new fraction called, so let me just write out what the code, what's an example of what the code would do. So for example, we could have something like fraction f4 equals minus f2, right? That's the kind of thing we would want to be able to write. Just like int b equals negative a. Was there a question in the back?
Yeah, why make the operator plus function non-member?
So the question is, why make the operator plus function non-member? It's a fantastic question. The simple answer is, there's a rule of thumb which states if your operator is symmetric in both of the arguments, make it non-member. It's not a rule, it's more like an intuition guideline. Most people would want to have the inclination to make operator plus a member because they would copy and paste the code and access the private variables themselves. But plus equals, thinking about plus equals, it favors the left-hand side to the right-hand side. Or not favors, but there is an asymmetry in the left-hand side gets modified, whereas the right-hand side does not. Okay? So that's an asymmetric relation between the two arguments, so we make it a member function. Operator plus is basically symmetric in the arguments. It doesn't really matter what's on the left or the right. It's going to have the same outward effect. That's the rule of thumb for whether to pick member or non-member. But beneath that is, do you absolutely have to modify the private member variables? If you do, you want a member. But even if you say to yourself, oh, well, operator plus, I have to access the private member variables, if you don't understand that there is a plus equals out there that you can do it like this, you might have a tendency to make everything member variable or member function. If that doesn't make sense right now, just watch the video again. Okay? That's part of the reason why I'm doing this taping. Okay? Because if I had been listening to what I just said right now, I probably wouldn't have followed it. Okay? So, that's part of the utility of the video. Okay? So when the parameters are symmetric in their sort of role, like operator plus or or operator times, then you want to make it non-member. But the rule of thumb is, right, if you have to access a private member variable, you make it a member function. Okay, so let's do the operator minus. This one I'm going to have to access, I'm going to have to modify, say, the numerator to be negative of what it was before. So that's my indication of, and I'm not going to call some other function to do it. I'm going to go directly to the private member variable, turn it into a minus, and then exit out. So I want that to be a member variable. So and in particular, what should be the return type? A fraction. We're going to create a new fraction out of this. Okay, so we do fraction operator minus. Okay, now there's no input parameters. Why? Yeah, because it's a member function, you're going to act on the object calling it. Okay, so there is no parameter. And I'll show you the different ways of calling it in a minute. Question? Yeah?
So the difference between the syntax of negating something and subtracting something is the number of parameters?
Yeah, so the question is the difference between the sort of binary minus and what's called the unary minus is the number of parameters. Yes, 100%. Okay? That's exactly how the compiler tells which function to call. Because operator minus the binary version, like a minus b, you're going to write the exact same thing, operator minus. But instead of no parameters, you're going to have two parameters. If it's non-member, then you have two parameters. Okay? So yeah, this is why it's called operator overloading. Because the same operator can be invoked in different ways depending if it's negative a versus a minus b. Okay? So all I'm doing is I'm just kind of refining. You already know intuitively what's happening, but I'm trying to make it very precise as to what's involved logically. So what do? We're going to create a new fraction called negation, maybe? I don't know. Oh, well, how would we construct this negation object? One thing I have to do first. That's my 2 minutes. Okay, so I'm going to do negative numerator, and then just put in the denominator. For example, right, I'm making a convention that the numerator is going to hold the information about whether or not it's positive or negative. Okay? Then there's a function we're going to write next time called reduce. It's going to simplify the fraction to its lowest common denominator, and it's going to make sure that the negative always stays in the numerator. Okay? But for now, let's just make the assumption that the numerator determines positive or not. And what am I going to return? Negation. Okay? Now, for example, I go back into this code here. And there we go. So the 2/3 hasn't changed from the beginning, and now I've changed it to 2/3, or negative 2/3. Okay? Just to show you how kind of messed up it can be, this is the same as fraction f4 equals f2 dot operator minus open close parentheses. Okay? So again, all we're doing is defining a function with the keyword operator in front of it. Why do we create a function with the keyword operator in front of it? It's so that we can call it either like a regular member function, or more kind of stylistically, much nicer, we can just write negative f2. And it does really what we think it should do when you put a minus sign in front of an object. Okay? So last thing to just mention is, how would you call operator plus? Here, well, it's a non-member function, so what you'd have to do is write something like f3 equals operator plus f2, and that's the same thing. All we're doing is defining a function with the keyword operator, And that gives us the freedom to call it in several different ways, some of which look a little bit more mathematical than others. Okay, see you on Wednesday.